here is our second video on the extension type problems for the sequences and series unit. This is number 6, the second part on your arithmetic workday practice. So you're given a series. Remember, a series is the sum of the arithmetic sequence terms. So the series is 2 plus 8 plus 14, on and on and on. And the question says, this is the extension question, if the sum, S sub n, is 420, so if I add up all these numbers, they equal 420, what is the value of n? In other terms, how many numbers did you add up? How many numbers are in the sum? That is what we're trying to find. So, remember, this is similar to the first video that we did. We need to identify what we know and what we need. Now, in this S sub n formula, the bottom formula here, it says you need an n. Well, remember, we don't know what n is. That's what we're actually trying to find. I need a sub 1. That's my first term. And when I look here, my first term is 2. And I need a sub n. I need the nth term. Now, I'm not given the nth term, and I don't know what n is, so I can't find it. But just like this, the video for the first problem here, we are going to, excuse me, we are going to write a little formula for a sub n, because while we don't know what the number for a sub n equals, we do know how to write an expression for a sub n, and that is using this top formula in green up here. This is a sub n. So in order to use that formula, I need my a sub 1, which is 2, plus n, I don't know what n is, that's okay, n minus 1, times the common difference. That's what do I add every time? Well, I'm adding 6. That's my common difference. So I'm going to do a 6 right here. Now, all I'm going to do is simplify that expression. I'll distribute the 6 here. I'll get 2 plus 6n minus 6. And I'll simplify that to be 6n minus 4. I'm going to write a little a sub n over here. So that's going to be really important for us. I need that a sub n in order to do this yellow formula to find the sum. All right, so that's all I know right now. So let's see. Let's jump back over to using this 420 and finding the value of n. So what I'm going to do, I'm going to recopy this formula over. This is the formula for the sum of an arithmetic series. So S sub n equals n over 2 times the first term plus the nth term. Now let's put in what we know. We know that S sub n is 420. So I'm going to put 420 here for S sub n. We don't know what n is. We do know the first term. The first term over here is 2. And we just found in this little box down here an expression for a sub n, which is 6n minus 4. Now notice, now in that green formula, the only thing missing, the only thing I don't have is n, and that's a good thing. So now we're going to simplify and solve that expression for n. First thing I'm going to do is simplify inside the parentheses. 420 equals n over 2 times 6n minus 2. I don't want that 2 in the denominator. So what I think I'm going to do, let's see. I could multiply both sides by 2, but then I think my numbers are going to get really big, and that'll equal 840 on one side. I think this time, because 6 and 2 are both even, I'm going to distribute the n over 2. I think, and again, just like the first video, I could multiply both sides by 2 here, but when I distribute that n over 2, I actually get 3n squared minus 1n, right? n over 2 times negative 2 is negative 1. And that just keeps the numbers a little smaller. If you want to multiply both sides by 2 and get 6n squared minus 2n equals 840, you're welcome to do that. All right, now we're going to have a quadratic here. So I'm going to subtract the 420 from each side, which will give me 0 equals 3n squared minus n minus 420. And I'm going to need to factor. I look for a GCF. There's no GCF here. So I'm going to use the method of split the middle. All right, 3 times negative 420. Let's see. Is negative 1,260. So I need two numbers that multiply to negative 1,260 and add to negative 1. There's a little negative 1 in there. All right, now, just like the first video, I'm going to suggest you pause this video and try to find for yourself the two numbers. It doesn't help you. I mean, you can sit here and just wait for me to stop talking and tell you the answers, but that doesn't actually help you. Pause the video. It'll just take you a minute or two. Find the two numbers, and then come back. All right, hopefully you did this work for yourself, but if you didn't, you take an easy way out. That's your choice. Here are your two numbers, 35 and negative 36. That's what's multiplied to negative 1,260 and add to negative 1. So now I'm going to split the middle. I'm going to leave this 0 equals here. The first term stays the same. The last term stays the same. And that middle term of negative 1 splits up into positive 35n minus 36n. And now all we have to do is finish factoring by grouping. All right, so my GCF for the first group is just going to be n. And it's the only thing. 3 and 35 don't have another GCF. And negative 36 and negative 420, I think it's negative 12. So I'm going to pull out a negative 12, and I'll have 3n plus 35. Yeah, that makes sense. All right, so my factor form here is n minus 12 times 3n plus 35. And in the first video, we said the way we solve this is using something called the zero product law. And the zero product law says you take each of these factors individually and set them equal to 0 and solve them, and that gives you both values of n that could set the expression equal to 0. So on the left side here, our solution is n equals 12. On this right side, I have to do a little bit of work. So I subtract 35, divide by 3, and n equals negative 35 over 3. So I have two choices here. Now our answer is going to be positive 12 because negative 35 over 3, first of all, that's not an integer. And remember, n is the number of terms. I can't have an integer or a negative number of terms that I'm adding up. So that can't be the right answer. 12 has to be it. So you add up 12 terms in this pattern. So you'll add 2 plus 8 plus 14 plus 20 plus 26, on and on. 12 of those numbers added up will give you 420.